This is an implicit differentiation problem because I have y's on both sides of the equation. Kind of x's and y's are all partying together, and because of that, I have to use implicit differentiation. The steps for which are here. The most important step here is that when we take the derivative of a y term, we tack on a dy dx. You'll see that in action when I tackle this problem. So the derivative of tangent is secant squared x minus y. Don't forget the chain rule says we need to multiply by the derivative of this inside function. The inside function is x minus y, so we're going to multiply by its derivative. The derivative of x is 1. The derivative of y would be 1, but except we have to remember that when I take the derivative of y, I tack on a dy dx. So we're going to say dy dx equals derivative of 2x is 2. The derivative of negative 3y would be negative 3, except again, I've taken the derivative of a y, so I tack on a dy dx. Okay. Now I'm done with step 1. I need to shuffle the terms around so that all the terms that have a dy dx go to one side and all the terms that don't have a dy dx go to the other. Unfortunately, this 1 minus dy dx is kind of a term, these are two terms trapped inside of this parenthesis, so I'm going to try and break them out by distributing the secant squared of x minus y to both terms here. Let's go ahead and do that. So secant squared x minus y times 1 minus secant squared times dy dx would be secant squared x minus y times dy dx. Equals, the right hand side doesn't change, I don't need anything to change over here. And now I need to shuffle terms around. I'm going to add this negative 3 dy dx over to the left, and I'm going to subtract this secant squared of x minus y over to the right. So here we go. I'm going to have 3 dy dx minus secant squared x minus y dy dx equals 2 minus secant squared x minus y. This marker is getting a little too squeaky for my tastes. Okay, so I've got two terms over here that have dy dx. I'm going to factor that out. 3 minus secant squared x minus y all times dy dx equals 2 minus secant squared x minus y. Last step would be to divide both sides by 3 minus secant squared of x minus y so as to isolate dy dx. So dy dx finally is equal to, I'm just going to do this. Let's draw a fraction bar and put this guy underneath. So he's going to go away. 3 minus secant squared x minus y, and that is your final answer.